Today, we're going to discover how a first-of-its-kind charger for electric vehicles has been integrated into an FRP utility pole and how this will help solve demand for services, especially in regional communities. Good morning and welcome to our webinar on the trial of an EV charger in an FRP utility pole. I'm Georgia Lance, Marketing Officer at Wagner's CFT, and I'm here with today's guest speakers, Essential Energy's Manager of Innovation, Brad Trethewey, Innovation Senior Analyst, Stuart Simpson, and Principal Engineer, Innovation, Paddy Atkinson. Brad is a Senior Manager at Essential Energy and an experienced electrical and computer systems engineer. He currently leads Essential Energy's innovation team. He has decades of experience in network asset management, standards and innovation within the industry in New South Wales and Queensland. Brad established Essential Energy's renowned quality assurance lab, which has led the transition to composite products within Essential Energy and more broadly across the electrical distribution networks. Meanwhile, Stuart is an Innovation Senior Analyst at Essential Energy, where he leads initiatives that deliver low-cost, sustainable electric vehicle charging solutions using existing infrastructure. Starting with the deployment of EV chargers on timber poles, Stuart has since led the development and trial of Australia's first in-composite streetlight column EV charger in partnership with Wagner's CFT. Passionate about practical innovation, he also played a key role in establishing the Innovation Hub in Port Macquarie, helping to foster a culture of experimentation and forward-thinking energy solutions across regional and rural New South Wales. Finally, Paddy is a principal engineer in Essential Energy's innovation team and an accomplished energy systems engineer with 18 years of international experience across 3 continents. His current focus includes integrating electric vehicle charging infrastructure into network assets, optimizing transforming capacity to support fast EV charging, and enabling vehicle-to-grid capabilities. He's also leading initiatives in early fault detection, battery energy storage systems, and site-based orchestration and optimization to enhance distributed energy, resource coordination, and grid resilience. We're also joined by Wagner's CFT Global Utilities Lead, James Lorimer, who will be facilitating the Q&A session at the end of the webinar. Welcome Brad, Stuart, Paddy and James. Before we get started, just a few webinar protocols. We are recording today's event and we'll make the recording public via the Wagner's CFT YouTube channel. You can ask a question anytime during the webinar via the chat bubble at the top of the screen. However, we will hold your questions over to the end of the webinar for the Q&A session. And for anyone having difficulties accessing the chat facility, feel free to text your questions to me on the mobile number that I will pop in the chat facility now. So let's dive into today's webinar. I will hand over to Brad.
Hopefully you can see the screen there. I think today we'll just commence with a bit of a recap of Essential Energy's journey with composite assets, and I'll hand to Stuart to talk through a recap of a previous trial that we've done with composite streetlights and EV charging, and then we'll hand to Paddy to talk through the details of what we've done with this particular trial. So without further ado, we'll get moving along. So essentially, it's been using composite assets for quite some time. We started some years ago, almost 20 years ago, looking at composite crossarms, and we went fully composite with our crossarm fleet in 2012. The behaviour and the outcomes of those composite crossarms have been exceptional. We've been very happy with those. We've done a lot of accelerated testing and aging at our lab facility in Port Macquarie. We started playing around with poles around about 2014, and we're now transitioning fully to a composite pole fleet. In addition to that, we've also been playing around with street light columns in composites, and we did a trial last year with a EV charger in it, which I might hand to Stuart now to talk through.
Thanks, Brad. So for those that haven't seen this or missed our webinar we did last year with Wagner's, we did a 4-week trial in Port Macquarie with the street light column on the right-hand side of the screen there. It is a fully integrated EV charger prototype that we put inside of this column. It's a 7 kilowatt charger that charges at about 40 kilometers an hour or so for an EV charger that comes along and plugs in. So this was a really successful trial we ran last year, and we ran it, as I mentioned, over a 4-week period, and we had an extremely positive feedback over the course of this trial. So from this, we took the learnings of this trial and we looked at, okay, what's next? And we announced last year in the webinar, it was about 12 months ago, that we were looking to do a next iteration of this product where we were looking to put an EV charger inside of a distribution utility pole. Brad, if you jump to the next slide. So moving to the distribution utility pole, there are a few additional challenges that came with this idea. So working with the partners on this, so Wagner's and ChargePost, we worked through these challenges to see how we can bring this idea into fruition, into the real world. So a couple of these problems: how do we fit a charger with a large enough opening fully inside of the utility pole without affecting the mechanical performance? So being we've got an overhead network with additional loads above the column, we had to make sure that we met all of our safety requirements and physical requirements for a utility pole on our network. How do we design this solution that it also meets electrical safety and metering challenges? Could we maintain the aesthetic appeal? So in the streetlight column we just showed previously, being fully contained, we had a lot of comments and a lot of positive feedback on the aesthetic appeal of that design being fully integrated within the column. So we wanted to continue with that aesthetics into this utility pole solution as well. There's also some regulatory barriers that we need to overcome for this solution. So we've looked at that in this solution as well, in this trial, on how we can look to satisfy those requirements as well. And also we had a question of, would customers respond positively to this solution as they did for the streetlight charger as well, which we'll go through some of that as well and share some of the feedback to date. So without further ado, this is a photo here on the right-hand side of that utility pole that we've developed. This solution has gone in at a site in Kew, which is about 30 minutes south of Port Macquarie. So as you can see, it carries that same aesthetic appeal of the streetlight column, fully integrated with the ChargePost integrated charger there. So I'll just talk you through some of the details of the site and the charger itself. So it is a 22 kilowatt 3-phase charger, can charge up to 22 kilowatts, giving up to about 120 kilometers of range per hour, depending on the vehicle and the restrictions of that vehicle. So it's got it's fully market ready. So we're using an off-the-shelf charger and a revenue grade meter that's fully enclosed behind the charger inside of the column. All the cabling is neatly concealed in the column. Paddy will talk you through some more of the intricate details of that as we go through this session today. And we've fully value stacked this composite transition. So as Brad mentioned earlier, we're moving through to a fully composite transition of our utility poles. And this is a solution that value stacks on that transition, where we can use this existing asset for additional purposes, such as integrating an EV charger inside of it. So this was initially a 3-month time box trial. We worked with the AER to meet certain requirements around this trial. The charge has been free to use for the general public, and there's a QR code, as you can see on the sticker above the charger there, where users were asked to come and fill out a survey and answer questions about their experience with the charger and some other questions as well. So the site, as I mentioned, it's just off the Pacific Highway, 30 minutes south of Port Macquarie in a small town called Kew. There's only around about 2,000 people in the general vicinity of that charger, and looking at the stats this morning, there's only about 17 EVs in the general area. So it was an interesting site. We worked with the local council on where they would prefer to see chargers, and we thought this would be a good solution to see close to the highway, but with a small population, what sort of customers would we see using the charger? So we had a number of questions around that, as well as some things around the site itself. So was there adequate parking? Where we believe we chose a site with good parking. It's also located near local businesses that could see benefit from the charging. As I mentioned, close to the highway, and it's also within 500 meters of a Tesla fast charging station that was recently commissioned there around the same time as we kicked off this trial. So I'll hand over to Paddy to go through some more details of the trial.
Sorry about that, on mute. Thanks, Stuart. Thanks, Brad. Just first and foremost, just want to sound out the partnerships we've had in this project. So clearly, Wagner's it's been great to work with their professional team on extending innovation in the way we are in this project. Also, just to mention ChargePost, who are the provider of the EV charger. They've got a slick bit of equipment that was originally developed and manufactured in the UK. It has the intention of in the UK. There's a lot of deployments within streetlight columns, so hence the very elegant and small form factor that helped us deliver this prototype in this project. So shout out to ChargePost, and also just to Port Macquarie Hastings Council for their support in selecting a suitable site and working with signage for this site. So move to the next slide. Thanks, Brad. So why put a EV charger inside a pole? What we're seeing in the transition to EVs within Australia is it's heavily dominated by the city centres, and the regional setting is seeing a far less uptake of EVs. And one of the things we believe that is due to is an inadequate provisioning of charge infrastructure. So we're aiming at providing another option for EV owners to charge their vehicles, and we see this as a way of doing that while stacking other functions together within an installation. So what we found with the streetlight charger feedback from the trial was that we had an overwhelming response from people to say that they thought that regional charging was either terrible or poor. So we got a bit of feedback from that to sort of echo what we're aiming towards with this work. Some of the things to say about the regional transition, that we believe that if adequate provision is provided, there is actually good benefit to the regional driver for a transition to an EV vehicle, in that regional drivers typically drive a lot further than urban people do, which can lead to increased fuel savings and carbon savings as well. So I'll get to jump to the next one. Thanks, Brad. Talk a little bit about the design process. So we worked hand in hand with the professional team at Wagner's to kind of mock out what was the best option we had by way of cutout for the pole. Clearly, we need a cutout to access the internals of the pole. The design challenge with that is the more material you remove, the more strength you reduce, and the tip deflection becomes an issue as you increase the cutout size. So we initially worked with Wagner's to give them a desirable cutout size with an idea to future-proof for other types of installation in the future. And there's a back and forth process around what was technically feasible against what we desire. And in the end, we arrived at a cutout size, which is 500 mils long and 100 mils wide. And that allows for the strength to be maintained and the tip deflection to be within the limits, acceptable limits. Initially, Wagner's were doing that by desktop, so they were telling us through their engineering models what was acceptable, and eventually we're able to do some mechanical testing to confirm the strength and tip deflection for the pole. So once we were in receipt of the pole, we were able to fit it out in the essential depot in the ready for installing the pole in the field with our line crews. That involves us running the cabling internally and the conduits, etc., and also making up a cover plate, which you can see in the bottom right-hand image there. We went with an aluminium cover plate in this instance, but in future we look forward to producing that cover plate out of something that's non-metallic, just to reduce the need for earthing of another component in the installation. I'll jump to the next one. Thanks, Brad. So, like I said before, the benefit of this kind of approach we see is we're stacking many functions in one asset, and in naming those, we've got the LV, the pole is supporting the LV conductors overhead. That same pole is also supporting a street light, as you can see in the photo, as well as LV residential services. You can see a service coming off the right-hand side of the pole there. We've got our charger internal, which Stuart sounded out that it's a 22 kilowatt AC charger. And there's also the scope for the provisioning of things such as 5G repeaters or CCTV in the future. So, yeah, stacking many things in one asset there. Brad, if you could jump to the next. So talk a little bit about what's inside our installation. As you can see in the middle bottom photo, the charger and the cover plate are attached to one another, which makes for a fairly elegant installation by way of when we need to remove the installation. We remove two screws, top and bottom, two security screws, top and bottom, that allow us to bring the entire installation out and lay it on a workbench next to the pole. So internal to the pole, we worked with Wagner's to get some backing to fix some of our internal equipment too. So Wagner's have installed a bit of composite flat bar in the back of the pole that is epoxied to the inside, and which allows us to have some substrate to screw to, which is a benefit in this case. Wouldn't want to be screwing into the sidewall of the pole itself. So on that backing plate, we've been able to attach a market-ready revenue-grade three-phase meter, as well as our protection, an RCBO protection, which is the residual current device, and a circuit breaker in one. And that is our point of isolation if we need to do any work local to the meter or the charger itself. Jump to the next. Thanks, Brad. So being a low voltage electrical installation, we obviously need to do our testing and commissioning, and we're governed by Australian Standard AS 3000 in this case, which includes the mandatory tests that would be required for an LV installation of this kind, including continuity, insulation resistance, polarity, earth fault with impedance, remote earth neutral integrity, and the operation of RCDs. In addition to that, we do some EV charger specific tests, which involves us to determine the protection clearance for some of the safety functionality within the charger. But also, we're also simulating faults that could occur on the EV or on the charge cable itself. So, for example, if someone turned up with a cable with a broken wire internal, we're able to demonstrate that the charger will respond accordingly and make the installation safe in that instance. Some of the other tests involve us just confirming the comms for the charger itself and the meter are talking to the back office via the internet, and also some load tests, which helps us confirm that the measurement that the metering is making is what we're expecting to see. So we provide a known load and compare it to the results we're seeing from the meter. So that's our testing. In terms of our connection, we've gone with a fairly standardized approach within Essential, which involves LV fuse link at the head of the pole. So we're taking off from the LV conductors via a fuse link. Then we're using single double insulated cabling inside flexible conduit, which passes into the pole at the head of the pole via a hole. And it's sleeved at that point and then mechanically restrained via a eye-bolt and shackle arrangement to avoid abrasion on the cabling that's subject to its own weight hanging down within the pole. And in terms of earthing, we've got an earth stake at the base of the pole, and the earth wire is also passed into the pole, so we're avoiding any cabling on the surface of the pole. So all wiring is internal to the pole, which adds to the sleekness of the design. So in terms of statistics so far, when we prepared this presentation, the trial had been underway for 14 weeks. During that time, we'd seen a total number of sessions of 57, and that averaged out at around 4 per week. And as you can see in the right-hand top graph, presenting our sessions per week, as you can see, it fluctuates across the weeks. But one thing we're happy to report is that we've seen sustained usage of the charger rather than peaking at the start and dropping off over time, and perhaps even, it's hard to say from this data, but perhaps even a little bit more usage as time's gone on. In terms of our charge sessions, we're seeing on average long duration charges of around 85 minutes. So people are choosing to turn up and charge for long chunks of time, which is nice to see. And our average charge rate is coming in at around 11 kilowatts. And as many of you probably know, the rate at which the charge is delivered from the charger is in an AC setting is dependent on the inverter on board in the car. And in most cases, that maxes out at 11 kilowatts. Some of the other analysis we've been doing is monitoring temperature and humidity within the pole, just to understand the operating conditions that the charge will be subjected to. The peak happened in this period in the initial phase in I think late September it was, and we saw a peak internal to the pole of around 41 degrees C. That was during a charge session and at a time when the ambient temperature was around 20 degrees C, so about 20 degrees above ambient. We're still, a little caveat to that is we've got two sensors in the pole. We're still working on positioning of the sensors just to make sure we're not getting any erroneous readings from the cable temperature itself. So we're working with that as we continue with the trial, and hoping to just gauge in the summer months what we're expecting to see as a true maximum in the hotter weather. So I'll pass back to Stuart now just to talk a little bit about some of the survey results we've seen.
Thanks, Paddy. Yes, as mentioned, we had the QR code on the pole there so users could respond to a survey. We did a similar thing last year with the streetlight charger, and we actually saw some very similar trends in the responses that we got. So we had some questions around the availability of charging in regional New South Wales, and how far and how often people would want to use chargers. What we saw and what the trend we keep seeing is that there isn't, most people believe that there isn't a good availability of charging in regional New South Wales, and actually state that as being poor or terrible. And most people also do not want to travel far for a charger, particularly a charger of this need. So what that sort of presents to us, or what we can take away, is that there's a number of use cases for varying types of chargers, level 2, level 3 chargers, depending on what people want to do. So with this one being in the vicinity of a hotel, a golf club, and a pub down the road, a lot of users want to come use this charger for an extended duration of time, either while they're attending one of the businesses or staying overnight at the hotel. So this type of charger more of those long-term stays where people don't want to travel too far away from their destination to use a charger. We also had 100% of respondents have an extremely positive response to this power pole charger. A lot of comments around the sleekness and aesthetic appeal of it. A lot of people found it really easy to use. And most people said they would use this charger at least once a week. We had a bit of a split between 1 to 2 times a week and twice or more in those survey responses. Brad, if you jump to the next slide, we had a section at the end of the survey as well, just for some verbatim comments around what people found appealing about the charger. So we had a lot of comments here around it being really easy to use, aesthetically pleasing, people really liking the concept, although there's not enough of them around. They liked the location of it. We also had some comments from the motel next door. So when I think Paddy and a couple of other staff have attended the site to do some work and visit, they spoke with the people working in the motel there, and they said they've had people come and stay in that motel specifically to use the charger as an additional amenity to use. And they've noticed that there's been some repeat people come and use the charger that live in the community nearby. So we've had definitely a mix of different people using the charger and a lot of different use cases, but overall some really good feedback and some really positive responses. So I'll pass back to Brad, who'll just talk through the next steps for us from here.
Thanks, Stuart. So as per the streetlight charger trial, this trial has validated the need for ubiquitous Type 2 EV charging in the public arena. Pleasingly, or perhaps not so pleasingly, the survey results, as Stuart mentioned, have aligned with the previous trial around the streetlight charger, which has suggested that in regional areas, over 60% of the people that have provided a survey response have indicated that the charging availability is poor or terrible. We believe that these sort of solutions integrated into existing infrastructure provide a value stack outcome, but also provide that service to regional New South Wales. The other thing is sort of what we're doing further as we look onto what we're going to do next is we're refining this particular design based off the trial learnings with Wagner's and ChargePost in a similar fashion to what we did for the streetlight charger. So with the streetlight charger, it was, I would say, probably a technical readiness level of around about a 3. We've lifted that technical readiness level with this particular trial up to a readiness level of around about a 7 or 8. So this particular installation can be deployed now in terms of the technical capability of it. It's market facing, it's got all the revenue requirements that are suitable. Some minor technical issues that we're resolving over the next few months will finally close the door on the technical aspects of this particular trial. What else are we doing? We're sharing our learnings with others so we can collectively accelerate the transition to electric vehicles and net zero target objectives that the government has set for the electricity distribution sector. And today's session is one of those examples of us sharing our learnings, and hopefully you've gained some information and some knowledge around how we approach this. We've been very open with how we've designed this, and certainly shown some interior design outcomes that we believe are of interest to all in this industry. Lastly but not least, we're exploring more ideas how we can value stack our transition to composite assets. So realistically, this is not the last thing you'll hear from Essential Energy in terms of leveraging our composite asset transition. So we've done the streetlight charger trial. We've now done a pole charger trial. There is another trial we are working on that will leverage the composite transition. And I'd suggest watch this space. We hope to make a really good announcement in the next few weeks. With that, I think I might hand back to Georgia for any questions and or James for any questions.
Brilliant. Thank you very much, Brad, Stuart and Paddy, for your presentation. And we're definitely excited to keep an eye out for that update on what's coming next. But before we jump into the Q&A session, I wanted to tell you very quickly about how Wagner CFT has debunked the top 10 myths about FRP utility poles and our Signature Series product range. As the electrical industry explores modern alternatives to traditional pole materials, understanding the facts about fibre reinforced polymer is essential. This clear and informative guide from Wagner CFT debunks 10 common myths about FRP utility poles. It explains how FRP technology outperforms traditional materials like wood, steel, and concrete in key areas such as durability, safety, and environmental impact. The document offers a fact-based perspective to help industry professionals make informed decisions about pole infrastructure. So if you'd like to read the full document and explore all 10 myths, use the QR code on the screen now, and I'll also include the link in today's follow-up email. With 25 years of experience delivering pedestrian bridge solutions across Australia and around the globe, Wagner CFT has unveiled a new product range aimed at making procurement faster, simpler, and more cost-effective for customers. The Signature Series is a collection of pre-engineered, off-the-shelf bridge designs created to meet the most common infrastructure requirements seen across hundreds of successful projects. Built on decades of experience and deep knowledge of Australian standards, the Signature Series streamlines everything from quoting to delivery while offering the same level of structural integrity and compliance that Wagner's CFT is known for. So if you'd like more information about the Signature Series, use the QR code on the screen now, and I will also include the link in today's follow-up email. I'd now like to welcome Wagner CFT Global Utilities Lead, James Lorimer, who will be facilitating the Q&A session of today's webinar. Let's have a look at some of those questions, James.
Good morning, all. There's some fantastic questions here, so we'll try and get through as many as possible. And if we don't manage to get through them, we'll definitely make sure that we follow up with some answers. But we'll start with a question from Ryan. What's the next phase of the trials look like? Outside of this trial, where did you see EV chargers and particularly embedded EV chargers in, say, 5 or 10 years? What is the particularly relevant regional networks? Might pass over to Brad for that one.
There's a lot in that one. Look, I think from an essential energy perspective, we see huge advantages in customers transition to EVs. And so in order for the EV transition to occur, there needs to be charging infrastructure. And Stuart mentioned during the presentation, we actually see that there is a need for a mixture of charging facilities. For example, if we went for all DC charging capability, there's simply not enough network capacity for that to occur. It's a significant investment and probably overcapitalization. So by having a variety of type 1 and type 2 charging capabilities across a regional footprint, you can diversify loads and you don't need to charge your car in 20 minutes. A lot of times people are charging for longer periods of time as they visit places of interest. And we see that with both of our trials. So getting back to where do we see this in the next 5 years, we would hope to see ubiquitous type 1 and 2 charging facilities across regional New South Wales, and this is part of the solution as far as we consider it. You're leveraging existing infrastructure and you're minimising the costs to the consumer in terms of producing charging facilities.
Fantastic, Brad. Thank you for that one. The next question's from Nick. And I believe Nick's got a few questions, so thank you, Nick. But we'll start with, did you make a calculation on the load increase of those circuits if you were to install many of these chargers in a car park light pole, for example? Would that be a Paddy question, or?
I think it's a combination of two here. We can talk to the streetlight one. I think you might get Stuart to talk to that. And then the pole one's a little bit more of an obvious answer in that there's already existing capacity in the overhead, but I might hand to Stuart for the streetlight one. Yeah,
I can talk through that quickly. So the streetlight one, for the site we had for that particular trial, we did do a study on the loads there. So it was actually, we had a large capacity circuit running to that streetlight. So we didn't have any concerns there for the load increase. But for other sites, we have looked at what our current infrastructure is with cable sizes going to those poles, and there are certain requirements we would have to put more of these in streetlights. We'd make sure that they meet certain load capabilities. But if we were to put more of these out, there are some considerations too. So those streetlights currently aren't on during the day, so we would have additional load during the day available to us to use for EV charging. Would be a good use case. Overnight, we do have additional loads on those circuits. So if we were able to implement some smart management, we might have lower rates overnight of charge and more through the day. But that's something that we want to look at in the future. Paddy, did you want to walk through the utility pole?
Yeah, I can say a little bit to that. So we've got a 22 kilowatt charger, which is around 7 kilowatts a phase. So the amount of load we're adding in this instance was so insubstantial with the infrastructure supporting the installation. We didn't really need to consider that. But if we were to furnish a whole town, like a main street of the town with these charges, then yes, we would need to do that exercise to confirm that we're not exceeding the capacity of this local infrastructure there. So hopefully that covers it.
Thanks, Stuart and Brad. I think this next one's briefly been answered from Brad, and I'm not too sure how much we can actually speak on it, but I will ask it, and Brad will see what we can come up with. What is the intentions after the trial? With the meter tucked away in the inside of the pole, it makes it difficult to move away from free charging. Is there an intention to move away from free charging?
For this particular trial, like in all things, when you put out infrastructure, you have to recover costs. So there is a commercial aspect to this if it was to scale. So yes, I think it's reasonable to suggest that you would pay for charging facilities as a recoverable cost outcome. The question is what do you pay and when do you pay? And there is a lot of discussion around network service providers such as ourselves around, well, what sort of tariff outcomes apply? And you might find that there's what we call dynamic tariff outcomes that incentivize daytime charging because the cost of energy is cheaper. In terms of the meter inside the pole, yeah, that is definitely staying there and as a revenue face or as a retail facing market meter outcome. And like I said earlier on, this concept we believe is at least a technical readiness level of 7 or higher. So it is a deployable solution.
Very good. Thanks, Brad. I think this next question is probably the cost could be different for any distribution network or electrical network. So I will ask the question. However, I'm not sure if it will be able to be answered today. But any cost estimate on the deployment of the existing poles for retrofitting? Is it feasible?
Oh, okay. That seems like a two-parter, James. The retrofit outcome, if there was an existing composite pole there and it was of suitable rated and we had enough capacity, we had enough mechanical capacity, I think you and I have had this discussion that we would be able to retrofit. And I think that's probably the first or the part of the question we can answer. Cost-wise, I would just highlight this is the first of its kind. You can always expect the cost of a first of its kind to be higher than a scalable product. So economies of scale really come into play here. How many can you deploy to get the cost and price point down? And we would anticipate, I won't quote figures here, but we would anticipate, based on what we've done already, at least a 50% price reduction to what we deployed with. Stuart, you want to add to that?
Yeah, I'll just add to that. So curbside charging using existing infrastructure is what we believe is going to be cheaper than sort of any other charging because we don't have to do any additional civil works to get to where a charger is going to be located. So we don't have to do trenching. We don't have to do additional overhead networks and whatnot. So using the existing assets should reduce the price significantly compared to putting a charger elsewhere.
I think one other thing to add there too, in terms of depending on the poles that were selected under our pole replacement program, we may be justifying the replacement of that pole anyway outside of the EV charging installation costs. So it would be a marginal cost to just equip the pole with the EV kit.
I think that's the important point to take away here is that existing infrastructure, when it needs replacing or it may be replaced for the purposes of putting these assets in, you already got some sunk costs that you're going to spend anyhow to put a composite asset in, and this is a marginal cost increase.
Very good. Thanks, guys. Now, the next question is from Caroline, and I think this is a good question. Were the charging sessions more often at night or through the day? If through the day, was it often or ever during the peak solar times?
Yeah, I can maybe speak to that. So yeah, majority of charging was in the day. We saw the exceptions being those ones that Stuart spoke about with people potentially who are staying in the motel who were charging overnight. The installation has restricted parking of 4 hours, so but that's seems to be adequate for what people are requiring. But yeah, most people, I haven't got it on my fingertips, but it was, I think the general charging period was from around lunchtime through to 3 p.m. was kind of the peak of what we saw. So it probably does coincide quite well with the peak solar times. But yeah, it's yeah.
Yeah, just add, I was just looking at the survey results. So we had a question around what time of day people would like to use these chargers. Over 50% of people said in the afternoon between 12 p.m. and 6 p.m. And the remainder of the time, 100% of people said between 6 a.m. and 9 p.m. So a good chunk of the people are looking to charge through the middle of the day or afternoon.
Very good. All right, well, we've got time for 2 more questions. One is, did the FRP pole have to be reinforced to allow the cutout, or is it simply a cutout from the standard circular hollow section? I can probably answer this one. Wagner's did a lot of internal testing. We have a fantastic R&D facility where we did full-scale testing to make sure that the cutout that we put in there didn't need any reinforcing. That's not to say that reinforcing isn't going to be a consideration moving forward, just purely because what we needed to do was to move up in pole size to be able to maintain the serviceability load. So yes, there's definitely a consideration to reinforce, and what that looks like will be a thought for the future and what that looks like. But at the moment, with our larger profile, we maintain the serviceability load. And we will finish off with a question from Nick. When you install these chargers in light poles, or I'm guessing distribution poles, do you have to change the switching of these circuits to keep power availability during the day, or were they just PE cell-driven lights? That would be yes for light pole itself, but I think the distribution pole has a light on as well, so works for both methods.
None of those circuits are controlled by PE cells for the street light, for the EV charger. So for the street light one, we had a separate serviced outcome and fused outcome, and you can see from the pole charger we ran a circuit specifically for the EV charger. So there's a circuit for the street light, circuit for the EV charger, and they're electrically separated.
Fantastic. Well, I do believe that we have a few more questions to be answered, but we are running short of time. So we will follow up with the answers hopefully today or this week at some stage. So we'll be in contact. But again, thank you very much to Brad, Stuart, and Paddy. I'll hand back over to you, Georgia.
Brilliant. So that concludes our webinar for today. A big thank you to Brad, Stuart and Paddy for their involvement, and also thank you to James for facilitating our Q&A session. If you'd like to share your thoughts on today's webinar, please feel free to complete the feedback form by using the QR code on the screen now, or the link that I will pop in the chat in 1 second. Or perhaps you would like to be a guest speaker. If that's the case, fill out the feedback form and let me know. You could also reach out to me on LinkedIn, give me a call, send me a text, however you want to contact me. I would love to hear from you. Coming up in November, we'll be discovering practical techniques and insider tips for successful fibre reinforced polymer construction and diving into real-world challenges, smart solutions, and lessons learned from the field, giving you the edge on your next FRP project. With guest speakers, Wagner CFT Custom Build Shed Supervisor, Ted Fechner, and Custom Build Team Leader and Carpenter, Guy Hargreaves. So if you're interested in this webinar, use the QR code on the screen now to register for your free online seat or to receive a recorded copy of the webinar. Link will also be in the chat and I will include it in the follow-up email today. That concludes our webinar for today. Thank you very much for coming, and we're going to go out on the video from the beginning of the webinar. Enjoy, and we look forward to seeing you next time.